all of you. Today we are going to see about characteristics of photons. First point, the energy of a photon is given by h multiplied by f. F is frequency. Usually they have a notation for frequency, they will be using nu. But for my convenience, I have taken the notation as f. F means frequency. So in most of the books, it is represented by nu only. So in the place of frequency, just remember the Greek alphabet nu is there. Okay. So energy depends on h multiplied by frequency. H is Planck's constant. So energy purely depends on frequency. Now lambda is equal to V by F. V is the velocity divided by frequency. So in the place of frequency, I can write V by lambda. V is the velocity divided by lambda. Where, since it is a photon, the velocity of light, which is c. So c value we know, which is 3 into 10 power 8 meters per second. That is the velocity. So the energy depends on frequency, or indirectly we can say the energy is inversely proportional to the wavelength. Okay. So this is the first point we have to remember. So in this point, we have 2 points. One point is the energy of the photon, which is h into f. So the energy increases if frequency increases, and the energy decreases, frequency decreases. This is the second point. Third point, we are talking about the momentum. Momentum P is equal to h by lambda, where h is Planck's constant divided by lambda. Lambda is equal to V by F. You substitute V by F, F will go to the numerator. Once again, if you see, h is constant. This velocity of light, that is c, 3 into 10 power 8 meters, that is also constant. So the momentum of the photon is directly proportional to the frequency. That means if frequency increases, momentum also increases. This is the third point you have to remember. Then fourth point is photons are electrically neutral. So photons are electrically neutral. That means if a photon travels like this, it is not affected by either by electric field or by magnetic field, because photons are electrically neutral. Then suppose if a photon and an electron collide with each other, then the total energy, the total linear momentum, the angular momentum are conserved. This is the next point. That means when a light hits an electron, that's what usually happens. So in the cathode, the light strikes the cathode and electrons are released. So during an interaction between photon and an electron, that collision will happen. So in that environment condition, the total energy, total linear momentum and the angular momentum are conserved. Whereas the number of photons may not be conserved. That means when a photon strikes a metal or a cathode in a solar cell, some of the photons may get absorbed by the metal itself. In some cases, the number of photons striking the cathode or the metal and the number of released photons can happen. So in that case, the number of photons may not be conserved. So you cannot expect, if 100 photons are striking a material, you may the number of outgoing electrons may be 50. So 50 photons it is observed by the particular material. So if that is the case, if you compare the number of incoming photons and the outgoing photons, in that case may not be conserved. The number of photons may not be conserved. So these are the some of the points that you have to remember while speaking about the characteristics of photons. The first point itself you have 2 points. One is energy equation. Second one is how the energy depends on frequency. Hope you have understood the characteristics of photons. Thanks for watching this video. Nandri.